All right, now we'll look at number 6. The graph shown shows the relationship between the number of cars on a certain road at different times between 5 a.m. and 9 a.m. In part A, you want to find the increase in the number of cars on the road between 6:30 a.m. and 7 a.m. Okay, so here's 6:30 a.m., which is right here, and 7 a.m., which is right here. Okay, now notice that increase right here. There is an increase by, and I will say approximately 50, because at 6:30 a.m. is 700. At 7 a.m., this is halfway between 700 and 800, which is 750. So if you subtract 750 minus 700, you're going to get 50. So in this case here, there were 50 cars between the hours of an increase in the number of cars. That's 50 cars between 6:30 and 7 a.m. Part B, the increase in the number of cars was the greatest between which times? Now here you have to look at how steep these lines are. In this case, this has the greatest steep right here between 6 and 6:30. That means at 6 a.m. there was 500, at 6:30 there was 700. That's the greatest increase, which is 200. So we can say between 6 and 6:30 was the greatest increase. And then part C, what was the increase in the number of cars between 8 a.m. and 8:30? Well, I'm going to go back to this figure between 8 a.m. and 8:30. Here's 8 a.m. and here's 8:30 right here. Here, the number of cars stayed the same between 8 and 8:30. So there was no increase in the number of cars between 8 and 8:30 a.m. So that will be 0 here. Then the number of cars decreased between which time periods below? Okay, again, now as you can see, it started decreasing between 8:30 and 9 o'clock. That was the only decrease that you can see there. So the number of cars decreased between 8:30 and 9 o'clock. Okay, so this is just an example of how to read a type of graph or a line graph to answer some of these types of questions. And number 7, determine if the graph on the right is or is not a function. Okay, now, if I write down the ordered pairs for these, like in this case here, this is 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5, 6. That's one ordered pair. Okay, and the other one, this is 7, 1, 2, and 3. And that's 7, 6. And then 7 and up 9. And the last one I think is 9 and 6. If you look at this, notice that the first component is the same. The first component is paired with 3 different second components. So that tells us that this is not going to be a function. Okay. Now, why would that not be a function? For the reason of the fact that I did state earlier that 7 is paired with 3 different numbers. So here, x equals 7 has 3 values for y. Because in this case, your y is 3, 6, and 9. So in this particular situation, it is not a function because you got x paired with 7, and then there are 3 values for y, for x equal to 7. And that should assist you with the homework problems in section 8.4.